Our last video on solving systems of linear equations is application problems. Number one, a rowing team rowing with the current traveled 40 kilometers in 2 hours. Rowing against the current, the team could only travel 16 kilometers in the same amount of time, 2 hours. Find the rowing rate, which we're going to call R, in calm water, and the rate of the current, which we're going to call C. So when you have a rowing team rowing with the current, that means that the current is helping, like pushing the boat faster. So when the current is helping, you can represent that as the rate that they can travel plus the current. So then that would mean when you're traveling against the current, that would be the rate minus the current. Next thing you want to remember is that distance is equal to rate times time. Therefore, we can set up these two equations with the distance on the left and the distance on the left. But we have to multiply the rate times the amount of time that they were traveling. And these are going to be our two equations. So what we're going to do is distribute that 2 across the board here and see if we can eliminate any of the variables. I also might want to rewrite these so that the variables are on the left-hand side, just because it's just easier to look at and it's very similar to what we did in our previous problems in our previous video. So if we distribute the 2 in both scenarios, we get 2c plus 2r is 40, and 2c minus 2r is 16. And you'll notice right off the bat that the 2r and the negative 2r are exactly the same. So all we have to do is add these two equations together. We get 4c is equal to 56. When you take that 56 and divide by 4, we get 14. So c is 14. C is the rate of the current. Then the rowing rate is what happens when we plug in C to one of the equations. So that means we can divide both sides by 2 to get 20 is equal to r plus 14. Then we subtract 14 from both sides, and we get the rate is equal to 6. So the rowing rate is 6 kilometers per hour, and the current rate is 14 kilometers per hour. Seems a little backwards, but that's okay. The employees of a hardware store ordered lunch from a local deli. The lunch consisted of turkey sandwiches and fries for a total cost of $38.30. So whenever you're ordering food, obviously turkey sandwiches are going to cost more than French fries. So we don't know how much they cost, so we'll say 4 for the sandwiches and 7 for the fries is equal to $38.30. The next day, the employees ordered 5 turkey sandwiches and 5 orders of fries for the total cost of $40.75. So what would the deli charge for a turkey sandwich, and what does the deli charge for an order of fries? So the sandwiches I'm calling S, and the fries I'm calling F. So you'll notice that this question, unfortunately, there is no easy way to cancel any of the variables. So what we're going to do is multiply the top equation by the 5 and multiply the bottom equation by the 4 to make it 20 so that we can cancel. So I'm going to rewrite both of the equations because it's a lot of math here to do in our head without rewriting it. So we have 3830 times 5 and 20s plus 20 fries is 163. So now it's very clear that the 20s will cancel if we subtract everything. So here we go. 35 minus 20 is just 15F. And 191 and a half minus 163 is 28 and a half. We divide both sides by 15 to get 1.9. That 1.9 is money, so that means that the fries costs $1.90. So to figure out how much the sandwiches cost, we're just going to take that 1.9 and plug it into one of the original equations for the F. So let's do the top equation. 4S plus 7 times F is equal to 38.30. So multiply that by the 7. We get 4S is 13.3. Subtract 13.3. We get 25. So 4S, oh, I put too many equal signs. 25. Divide both sides by 4. And we get that the sandwich costs $6.25. So the sandwich is $6.25. So now we have one more question, very similar to this one. A baker purchased 12 pounds of wheat flour and 15 pounds of rye flour. So we don't know how much each of them costs, but we do know that there's the 12 pound of wheat flour, which we'll call W, and the 15 pounds of rye flour, which we'll call R. When they bought them, it made a total of $18.30. Second purchase at the same prices included 15 pounds of wheat and 10 pounds of rye. So that was $16.75. So unfortunately here we don't have very good matching numbers, but I think, and correct me if I'm wrong, I know you can't actually talk to me at this moment, but you can send me an email. 15 and 10, I think we can get them both to be 30. So instead of multiplying the top and bottom equation by the same number, we can actually just find a better number that's going to work, like a smaller one. Because 15 times 2 would be 30, and 10 times 3 would also be 30. And I'll show you that right here. So distribute the 2 across the board. We got 18.3 times 2, 36.6. And we have 45W, 30R, so 5 times 3, 50.25. So you'll notice here when we subtract the equations, we can actually cancel out the 30s. You get negative 21W equals negative 1365. And we'll just divide both sides by negative 21 to get that the pound of wheat flour costs 65 cents. And we're going to take that decimal and plug it into one of the original equations for W. So we could do the top equation. It doesn't really matter which one you choose. Okay. Okay, 15R is 10.5, and divide both sides by 15 to get that R is 0.7. So the rye flour costs us 70 cents. And we're done.